Hello, geometry students. Today what we're doing is we're learning addition postulates. So we're going to do two addition postulates today. It's going to be the segment addition postulate and the angle addition postulate. So first we're starting off with the segment addition postulate. So my segment addition postulate says if 3 points A, B, and C are collinear, if we remember collinear means they're on the same line. So I'm going to draw 3 points and I'm going to put them on the same line. Okay. They told me B is between A and C, so I'm going to say A, B, C, where B has to be in between it. They didn't say B was the midpoint, so it doesn't have to be halfway between it. It just has to be somewhere between it. So A, B, and C, if 3 points are collinear and B is between A and C, then what my postulate says is that segment AB, which is this part right here, plus segment BC, which is this part right here, will be equal to the entire segment, which is AC. So my segment addition postulate says AB plus BC equals AC. If I have a point in between two points of a segment, I can add the two segments together and it equals the total. So again, another way of thinking of it, I can actually put numbers there. Let's say that AB is 7, that distance is 7, and BC has a distance of 4. Then we know that AC will have to be 11 because 7 plus 4 is 11. See? Simple enough. So now we're going to practice some problems where we do it. So I have segment BT and I have point A in between them. Again, it's not the midpoint. We can look at this and see it's not the midpoint. It's just somewhere between them. Well, BT, which is this entire segment, I'm telling you is equal to 36. I'm going to let us know that BA is equal to 8x minus 14 and that AT is equal to 2x. So in the end, what they want us to do is they want us to find the measure of BA and the measure of AT. Well, using my segment addition postulate, I know that if I add BA and AT together, I get the entire part, which we just said was 36. So BA, segment BA plus segment AT equals segment BT. BA, 8x minus 14 plus AT, 2x equals BT, 36. So now from here, it's just all algebra. So the geometry is knowing I can add these two together to equal this. That's the relationships. Now everything else from here is just algebra. 8x plus 2x, I'm combining my like terms. 10x minus 14 equals 36. Now I got to get the variable on one side, which it is. So I'm going to get the number to the other side. Minus 14, I add 14, so I can cancel out. 10x equals 50. Divide both sides by 10, x equals 5. Notice how neat I did when I showed my work. When you are doing your work, you got to show your work, but also show it neatly so we can read it. You have to show work to get credit. I didn't answer my question yet because they didn't just ask me what x was equal to. They asked me to find the measure of BA and the measure of AT. They wanted the distance of these points. So if BA is equal to 8x minus 14, I just need to plug 5 in for x since we know x equals to 5. So 8 times 5 minus 14. 40 minus 14, that is equal to 26. Well, if BA is equal to 26, and we know that BT is equal to 36, AT should be easy. We know that AT has to be 10. because 36 minus 26 is what's left, which is 10. Now, if I couldn't just come up with that on my own, again, I can just do what I did before, plug it into the formula. Plug it into the expression that they gave me. If AT is equal to 2x, substitute 5 in for x. 2 times 5, that's 10. So AT is equal to 10. BA, 26. AT, 10. So that's what my addition postulate is saying. My segment addition postulate says MA plus AN is equal to MN. So here they're telling me that MA is equal to 5x minus 3. So I'm going to plug that there in my picture. And then they're telling me that AN is equal to 30. In order to solve anything, I need to know what this whole thing is equal to. Because these two don't have to be equal, remember that. It's just in between it, but it did not say it's the midpoint. It did not say anything about bisecting. So we cannot assume that. The only thing that we know is that these two added together equals the whole part. So I'm going to tell you that MN is equal to 8x plus 6. Now we should be able to set up an equation to solve for x. And that's all they're asking us to find here. It says find x. Well, I know that these two together add up to be the total. So the geometry is knowing that relationship. 5x minus 3 plus 30 equals 8x plus 6, because that's what MN is equal to. Now I solve that equation. Again, I just got the habit of drawing that line. That's my balanced line. I know I got to be equal. Whatever I do to one side, I must do to the other. Before I start moving anything, I'm going to see if I combine any like terms. I do have these like terms right here that I can combine. Negative 3 plus 30, that's 27. So 5x plus 27 equals 8x plus 6. No like terms to combine. I like my variable to be positive, so I'm going to subtract this 5x. I'm moving that over. That cancels out. 27 is equal to 3x plus 6. Since my variable is on this side, I need to get the numbers to the other side. So minus 6 minus 6, 21 equals 3x, because that canceled out. And then I divide both sides by 3 to get that variable by itself. X equals 7. Since the problem only asked me what x was equal to, I know I don't need to go any further than that. Excuse me. So in this unit and throughout geometry, a big part of algebra that we have to know how to do is solving. So we have to know how to solve. So I just want to go over a couple of solving real quick. That's what this part is doing. If you don't know how to solve, come for tutoring. We can help you out. We might even be able to show you how to do something on a calculator if you don't know the trick. Okay? So this example, this is an easy one. This is just a two-step equation. I'm going to draw my line, and then, okay, I need x by itself. First thing I need to do, move the number. Is a positive 1, I subtract 1. 2x equals 8. Then I divide both sides by 2, x equals 4. Those are the easy ones. Those are the ones we like. Two-step equations. This one got a little harder. Before I start moving everything, I gotta make sure that each side is simplified. This side is not simplified because I can combine like terms. My 2x and my negative 5x. So I'm going to combine them. 2x minus 5x, that is a negative 3x. So negative 3x plus 1 equals 9. Now it's a two-step equation. Now it's easy to solve. I'm going to subtract 1 from both sides. Negative 3x equals 8. Divide both sides by negative 3. X equals a negative 8 over 3. I'm just going to leave it like that. It's going to be that fraction. This isn't a pretty number. That's okay. It's not always going to be a whole number. Sometimes you get decimals. Sometimes you get fractions. My next one, again, I'm going to draw my balance line. There's nothing I need to combine. So there's no like terms to combine. So what I need to do on this one is I need to get my variable to one side first. So I have the variable on both sides. I like my variable to be positive, so I'm going to add this 3x to both sides. That's going to cancel it out over here. So 5x plus 1 equals 11. Now I got my two-step equation again. It's my two-step. So I'm going to subtract 1 from both sides. 5x equals 10. Divide both sides by 5. X equals 2. This is going to be our last review question. So again, I draw my balance line. Okay. Before I start moving anything, I'm going to make sure that I combine my like terms. So 2x and 3x, they can be combined. 2x plus 3x, that's 5x. This 1 and this 4, they can be combined. 1 plus 4, that's 5. 5x plus 5 equals, there's nothing, well, I can combine these numbers here. So 19 and negative 5. 19 minus 5, that's 14, plus 3x. Now that I've combined my like terms, now I need to get the variable to one side. Again, I want my variable to be positive, so I'm just going to subtract 3x from both sides. 2x plus 5 equals 14. Now I got my two-step equation. I'm going to subtract 5 from both sides. I'll move this over here. 2x equals 9. 14 minus 5 is 9. Now I need to get the variable by itself, divided by 2. X equals 9 over 2, or 4.5. Again, that was not such a pretty number, but it's okay. Now when we turn to the back side, our back side is talking about the angle addition postulate. So my angle addition postulate is very similar to the segment addition postulate. First thing I'm going to do is I'm going to draw this angle that they're talking about. So angle DOG. Since O is in the middle, O has to be my vertex. So DOG. Now they're telling me if point B is somewhere in the interior. The interior is inside the angle. So all this area right here, this is my interior. They're telling me that B is somewhere inside there. So that's B. And I'm just going to draw a ray with B there. So my angle addition postulate says if B is in the interior of angle DOG, then the measure of angle DOB, which would be this angle right here, plus the measure of angle BOG, which is this angle right here, will be equal to the measure of angle DOG, which is the entire angle. So again, so like let's say that I said angle DOB, that was angle 1, and angle BOG is angle 2. What my postulate is saying, angle 1 plus angle 2 is equal to this entire angle. It's equal to DOG. So if angle 1 was 30 degrees and the measure of angle 2 was 35 degrees, then I know the measure of angle DOG would be 65, because 30 plus 35 equals 65. Okay? So if we look at these two examples down here, this is our given. So they're telling me that MAT, which is this angle right here, is 60 degrees. So I'm going to write that down. MAH, well, that's my entire angle. That's the total. I'm going to tell you that your total is equal to 140 degrees. And then that TAH is equal to 4x plus 20. They want you to solve for x. Well, using my angle addition postulate, again, I don't know that these two are equal because they didn't tell me this was a bisector. So I can't say that these are equal. I can't make that assumption. But what I do know is that angle MAT plus angle TAH, that's going to be equal to the entire angle, angle MAH. So if I put that there, MAT, 60 plus TAH, 4x plus 20, that equals the entire angle, which is 140. So whenever they're giving me a lot of information like this, I'm gonna somehow identify what the total one is, because then I know I need to add the other two parts together to equal that. Okay? Now from here is go back to that solving, that algebra I said you're gonna use a lot in geometry. First, combine these like terms. 80 plus 4x equals 140. Subtract 80 from both sides. 4x equals 60 divided by 4. X equals 15. Now, they just asked me to solve for x, so I'm done. If I go to the next one, it's the same thing. LOE, that's the entire angle. That's my special one. That's what I know it's all got to equal to. So I'm going to tell you that LOE is equal to 84 degrees. LOV, which is this angle right here, angle LOV, they told me is 4x plus 1. The measure of angle BOE, which is this angle right here, is 5x plus 2. Now and again, these two do not have to be the same. But what we do know is that when you add those two smaller angles together, it equals the entire angle. So I can say that 4x plus 1 plus 5x plus 2 equals the entire thing, which is 84. Combine my like terms. 9x plus 3 equals 84. Then I'm going to subtract 3 from both sides. 9x equals 81. Divide both sides by 9. X equals 9. Again, I'm sorry I didn't draw my line to start off with. They asked me to find x. I finished that. But now when I go here, not only did they ask me to find x, they want to know what the measure of angle LOV is. So if they told me that the measure of angle LOV is equal to 4x plus 1, now that I know x is equal to 9, I need to substitute that into the expression. 4 times 9 plus 1. 4 times 9, 36, plus 1, 37. So the measure of angle, LOV is equal to 37 degrees.